So we're going to talk about doing synonyms, how to do synonyms right. Now this is a really big topic actually, and we're going to do our best to fit it into 40 minutes. We're mostly going to focus on how to implement synonyms with a focus on multi-word synonyms and getting that to work right with positional queries in Solr. What we're really not going to spend a lot of time talking about is how to pick the right synonyms for your specific use case. It's really unique to everybody's own search situation. To start with a little bit, my name is John Marquiss. I'm with Wolters Kluwer. We're a multinational publisher. I focus on our health division. So we have a very specific problem with synonyms where we're using technical terms, which are usually multi-word to begin with. So we've been looking at a solution for this. We're going to talk about why to use synonyms, where to get them, how to use them, what your options are in Solr to implement synonyms, a special solution that we've utilized to solve multi-word synonyms before we had the synonym graph filter, and how to choose what solution is going to work best for you. So the first thing we're going to talk about is why to use synonyms, and it's really all about recall. You have users coming in, throwing terms at your search engine, and there's a disconnect between the terms that the user might think to use and the terms the authors of your documents are actually using in their content. So the example I have here is, a user might come in look for boat. Well, should they see rowboats? Should they see sailboats? Should they see dinghies? They probably don't want to see ships or aircraft carriers. So that goes back to picking the right synonyms for your use case, understanding what your users are looking for and how your authors are producing their content. Synonyms aren't a silver bullet, of course. They're not going to solve all the problems. And the biggest issue with improving recall is you're usually going to hurt your precision. Okay, so now you're bringing back rowboats. The user probably didn't want rowboats, maybe they wanted sailboats. So that's that precision problem. So choosing your synonyms, it's always that balance of helping the user find the content that's relevant to them and trying to filter out that content that's really not. Synonyms are also a hammer you're going to smack your queries with, and it's going to be a little bit of overkill, because you're not sense aware. Especially in the English language, a lot of words can have multiple senses to them. Again, another example is aircraft. A synonym for aircraft is a plane. A plane can also be a woodworking tool. Should you be showing users that are searching for aircrafts, Piper Cubs, Boeing 747s, woodworking documents? So again, that's going to be controlled by selecting the correct synonyms for your use case. So where can you get synonyms? Like we were talking about in those examples, the best synonyms are going to be built yourself. You're going to look at your queries that are executed. You're going to look at any of the sources you might have for your content set. In the medical space, we have UMLS, the Unified Medical Language System. You have SNOMED. And you're going to build up synonyms that are going to be best suited to your users and your content. That's a lot of work, though. So you can look at other sources like WordNet to get bootstrapped here. WordNet's a great resource, but you're probably going to customize it to get good results. Another interesting idea is you can generate synonyms automatically. That's a whole nother topic we could spend an entire day on. But the basic idea of that is co-occurrence, and that's words that uniquely occur next to each other or in proximity to each other are usually somehow related. Take, for example, think of blood sugar and insulin. You're probably going to find those in the same document in close proximity. So if you're intelligent and thoughtful about it, you can say, hey, maybe there's a correlation there. If I'm looking for documents that are about blood sugar, I also want to see documents about insulin. So you have your synonyms. You got to set it up so Solr can use it. The easiest way to use this is the Solr synonym format. It's a flat text file, one line per one synonym per line. And the file defines a synonym. And you can do one of two different formats. You can either have equivalencies, which are just A, B, and C, or you could have directed replacements, where you can use the arrow operator, where you can have a comma-separated list of terms replaced by another set of terms. So in this example, if I have a token A, when that goes through my synonym filter, it's going to be replaced by the tokens A, B, and C. With the directed replacement, if I have a token Y, it's going to be replaced by tokens L and M. Now you notice that Y is not a synonym of itself with direct replacement. So that's something you have to keep in mind if you're going to use that. In a lot of cases, you're just going to see direct equivalences, and you're not going to use directed equivalences. Directed equivalences are good for stuff like if you're going to model mesh, which is a tree-based thesaurus, and synonyms, where you have, non-medical, a German Shepherd's a dog. So if I search for dogs, I might want to see content about German Shepherds. On the other hand, if my user searches for German Shepherd, they're all using specific terms. I don't want to go up and just search for dogs now. So that's a case where a direct replacement might be beneficial when you're setting up your synonym files. You have a few other options. As of, I believe, Solr 4, don't quote me on that, they included a WordNet processor that allows you to directly consume the WordNet Postgres files without editing. For that same reason we talked about before, with synonyms being really use case specific, you're probably not going to want to use WordNet directly anyway. So you're probably better off just generating your own synonyms file. If you're going to do that, just go ahead and produce synonyms.txt in the Solr format. You also have the option of overriding and extending the synonym map builder. So you can really consume any input stream you'd like for your synonyms. In our experience, again, you're doing the work to process that input stream, you might as well just produce Solr XML, not Solr XML, but the Solr synonym format, and consume that as well. It keeps your implementation a little cleaner and a little smoother and a little bit easier to debug. So you have your synonyms. You've produced your synonyms text, and now you want to configure Solr to use that. So up until about Solr 6.4.1, your only option really was the synonym filter. It's a good general solution. It works great for single word synonyms. It's fast, and it's fairly efficient on indexing. It doesn't handle multi-term synonyms really well, though. There are some workarounds you can do that we'll talk about later to get multi-word synonyms with the synonym filter, but it's not going to work out of the box. Now, as of 6.4.1, this is deprecated, and you should move to the Solr, the synonym graph filter instead. This is your Solr XML for configuring it, and I've shown both the index analyzer and the query analyzer. In most cases, you're only going to use one. You're not going to do the synonyms both at index time and at query time, with a few special use cases that we'll talk about, and again, a little bit later in the presentation, really to solve that multi-word synonym problem. The other option, the synonym graph filter that's available in 6.4.1 and later, it really is a nice filter. It replaces the synonym filter. It provides correct handling out of the box of multi-term synonyms. It has excellent query performance. It is a bit more expensive at index time and an index size. But as you'll see, you probably won't want to use it at an index time anyway. If you do use it at index time, there's an extra step you have to go through, and that's part of the cost in using it, is you have to flatten the graph that it produces in order to fit in your index, because the index is really just a flat list of tokens, and it's not going to know how to handle a graph produced by this. So there's some configuration options with these. And fortunately, both of the filters use the same configuration. There's really good documentation on the Solar site that goes into much more detail than we'll talk about here. And in general, the defaults are rational and work well for most use cases. I do want to call out one particular parameter here, though, and that's the expand. The expand parameter is talking about what to do with the synonyms when you see those tokens. So if you remember back a few slides ago, the equivalency is A, B, and C. If I see B and expand is true, it's going to emit, my synonym filter will emit all three tokens, A, B, and C. Expand false says just emit the first token. That'll be important for us later for solving multi-word synonyms. So let's start putting it into practice. Let's talk about what happens when you use a synonym at index time with the synonym filter. Let's take a sample from our synonyms text. We're talking about Yeti and his friend, the abominable snowman, and take a string synonyms, Yeti sightings. How's that going to be processed by our analyzer? The string tokenizer is going to give us two tokens, Yeti and sightings. The lowercase filter factory that we use is going to basically give us those same tokens because it's already lowercase. And then the synonym factory is going to say, well, Yeti has a synonym that's abominable snowman. Abominable snowman goes through the white space token filter factory itself. So it's broken into two tokens, abominable and snowman. Now, if you look at the position of these tokens, they're position one, but now we have a problem. Snowman and sightings are both at position 2. So we don't have correct positional searches anymore. If I search for abominable snowman sightings, we're not going to find that as a phrase with these token positions. So let's see if the synonym graph filter can do any better. At index time, using the same example of Yeti and the abominable snowman, we see that our string tokenizer emits the same tokens. It goes to our synonym graph filter. Our synonym graph filter says, well, Yeti's a synonym for abominable snowman. So let's expand that. Now we have a graph, so we're a little bit more position aware. And the graph filter says, hey, my longest synonym for this term is 2 tokens long. So let's push sightings out to position 3 now. Okay, so we're seeing that positional awareness come in, but it's still not quite right. Because if I do a phrase query for abominable snowman sightings, that's going to work. But now I've broken that search for Yeti sightings because Yeti and sightings are no longer adjacent to each other. On the query side, though, the story gets a little bit better. And a little bit worse if you're still on something before Solar 641. If we take the synonym filter and we see what happens to that phrase search for Yeti sightings, it gets really confused. It's going to expand abominable snowman. It's going to say, well, hey, a snowman's at position 2, sightings are at position 2, so let's kind of munge it all together. And we get Yeti abominable snowman sightings. Now, at first, when you do the search, you might see your document come back. And you think, hey, it worked. Because Yeti sightings is a valid phrase for that first query. But the problem is abominable sightings is also a valid result. Yeti snowman is a valid result. And what's not a valid result is abominable snowman sightings. So I've missed some of the documents that should have come back, and I've killed my precision by returning a bunch of other documents that shouldn't have come back. So the graph filter, though, at query time, is building a graph. Because it has that graph of terms, it can construct the correct operators to give us truly correct positional phrasing. So it's going to search for the or of Yeti or that near phrase of Abominable Snowman, and then it's going to put that near sightings. So what's this mean? At query time, using the graph synonym filter will give us correct positional searches, whether they're one-word synonyms to one-word synonyms, one-word synonyms to two-word synonyms, two-word synonyms to one-word, or even longer, 3- or 4-word synonyms. There is a small problem, though. Because I'm going to implement my synonyms at query time, I'm going to effectively do a search for those two different terms, Yeti and Abominable Snowman. What happens in my document set if Yeti is mentioned 4 times and Abominable Snowman is only mentioned once? Well, he's more unique, so my IDF is going to boost his result. That may or may not be a problem. If you can imagine if you're in a problem space like medical research, and you take 2 terms like stroke and cerebral vascular accident. Cerebral vascular accident, a technical term for a stroke that might be more unique and not occur as often. So if I do the synonym search for that, those documents will get boosted. Now, if the target for my search are clinicians, they're probably interested in those technical documents, so that might be a nice, happy coincidence. On the other hand, if my search was targeted towards patients, you know, those technical documents maybe aren't so helpful to a patient. And really, just documents talking about stroke would be more beneficial. So that's why that boosting that comes from rare synonyms may or may not be a problem, depending on your use case, but it's something you'll have to consider. The easiest way to manage that is to be selective in what you use for synonyms. The other solution we're going to talk about is, what if you're not using Solar 641? Or what if this boosting for rare synonyms really is a problem? Well, we can solve this problem with that ExpandFalse. What we're going to do is we're going to assign UIDs to all of our synonyms. And instead of expanding all of our tokens out to the full list of tokens available to that synonym, we're just going to emit the UID. That flattens things out. Everything's going to have the same relevancy, but it's also going to make sure that our positions are always consistent, because it doesn't matter the actual length of the term. So what's this actually look like? So here's a larger snippet of our synonyms text. Now earlier, I actually lied to you. I told you that the Solar synonyms format is 1 synonym set per line. That's gone now. We're actually seeing that we have synonyms on multiple lines. Yeti and Abominable Snowman are the same synonym, but we're going to trick Solar. We're going to give them that same consistent UID between those. So what happens when Solar replaces every occurrence of Yeti with the first occurrence of its synonym definition, and every occurrence of Abominable Snowman with its first occurrence of a synonym definition, they're going to both emit the same token. So our configuration, this configuration will work for either the graph filter factory or the synonym filter factory. You just make that one replacement. And also keep in mind that if you do use the graph filter factory, you would also include your flattened graph. So now what happens? Taking that same example of Yeti and Abominable Snowman and looking at this during recent Abominable Snowman sightings, how does that get analyzed and how does that query get processed? The string tokenizer gives us 4 tokens: recent Abominable Snowmans and sightings, from our snippet, we're not looking at synonyms for recent or sightings. So we have recent. Now we're just going to emit that first token for that synonym definition, which is the UID we assigned to that synonym set, and sightings. Now if you look at the positions, though, they're position 1, 2, and 3. It doesn't matter that Abominable Snowman was 2 tokens long. We're just going to emit that UID, which is 1 token. Now if we step down to a search for recent Yeti sightings, we're going to see that's a very simple replacement. It's the terms recent, the UID for that synonym set, and sightings. It doesn't matter that Yeti was 1 word. It doesn't matter if Yeti was a 3-word token. It's getting reduced down to a single word, so that's going to match that phrase that I have in the index. Now this solution works with either the graph filter factory or the synonym filter factory. So if you're not on Solr 6.4 or later, you have a solution that works for positional queries with multi-word synonyms. So what should you actually use? Assuming that you want correct positional queries and you have multi-word synonyms, you really only have 3 options at work. The graph filter with UIDs, or the synonym filter with UIDs. So you got to pick. Now, we like making decisions based on data, so we have some analysis here. This is just done on this laptop here with an i7, 16 gigabytes of RAM. And I'm going to use the American National Corpus, which is an excellent resource. It's about 10,000 documents covering various types, technical papers, spoken language. There's about 15 million words, and I'm going to use the WordNet as my synonym source. I'm going to include multi-word synonyms. So it's going to be about 54,000 synonym sets with about 143,000 terms. So what this looks like, at index time, we're going to see that the indexing cost of not including synonyms, of course, is the best. The graph filter factory is more expensive than the synonym filter factory by about 30%. But again, the graph filter factory at at indexing time didn't give me correct positional behavior anyway. It's the graph filter factory at query time that I really want to use, which is going to have no cost on indexing. The index size, there's really no difference between the synonym filter factory or the graph filter factory. At the end, they're emitting the same tokens. Not using synonyms, of course, is going to give the smallest index size. So if indexing time is important to you, query time is the way to go. That's a problem if that rare synonym boosting problem is a concern for you. But if you can use it, use the graph filter. Now, how does the query performance look? And this was actually a little surprising for us. We expected the graph filter to be more expensive than it was. Now, I could have cheated it. I could have set the range to like 140 to 120 to 140 and kind of exaggerated the differences. But really what we're seeing is there's no more than a 10% difference in the performance of even the worst case expansion approach to not doing synonyms at all. And that was actually the synonym filter. Part of the reason for that is because of the way you expanded the query. You bloated your term counts, and you got some really complex positional queries that were really meaningless. And that caused a little bit of extra expense on the execution of the query. The graph filter factory actually ran, in this example, at about 4 to 6% more expensive than not doing synonyms at all. And this was just 20,000 queries randomly sampled from my WordNet synonyms. So again, all of this is telling us that your best option really is to use the synonym graph filter at query time. It's going to be positionally correct. You're not using deprecated code. The other advantage using synonyms at query time is if you want to change your synonyms, you don't have to reindex your content. You change your synonyms and then they're live. They're right there. If that rare synonym problem, though, is a problem for you, see if you can solve that by changing what synonyms you define. If you're doing that stroke and cerebral vascular accident and all the cerebral vascular accident documents are coming to the top because it's just used so infrequently compared to stroke, and that just doesn't fit your user's needs, ask yourself, is that really a useful synonym then? If the answer is yes, but you need to control that boosting, can you account for that by searching another field? Have a synonym expanded field and have a synonym a field that's not synonym expanded, and boost the non-expanded field so that that original term that the user used can carry more weight. If you can't do that, and you still have a problem, you still want to use synonyms, but this boosting is still a problem for you, then your only option is really to go with that UID approach. The cost of the UID approach is you're going to get relevancy at the cost of index size and indexing time, and then you also lose that flexibility of being able to change your synonyms without reindexing your content. And then also, if you're still on Solar 6 or Solar 5, you really don't have multi-word synonyms that are going to be positionally correct. Ask yourself, can I go to 641 or later first? Try to get on the more recent versions of Solar. If you can't, you can still go back and use UIDs with the synonym filter. Okay, thank you. Any questions? Go ahead. If you're only searching on that synonym field, because they're the same thing, but that's basically what your synonyms are telling you, that if my user is searching for this term, they're also interested in that term.
John, you mentioned earlier that co-occurrence, I know you didn't talk about
Yeah.
it, but one of the classic examples of that is WordNet, which is an analytic tool, you probably aware of it. But what it does is it finds words that are similar because they co-occur. But it doesn't know the difference between a synonym and a noun phrase completion, for example, or a related term. So I'd be very careful, put a caveat on that, and I've run into this situation myself. Related terms are not synonyms. And John also mentioned the hammer-nail thing. People tend to use synonyms as a hammer to fix relevance problems, and they include things that are really not lexically synonyms, and that causes other problems. But I love your UID thing. That's really cool.
Thank you. Now, anybody who's really paying attention, you don't technically need UIDs. You're just going to replace it by the first token that's in that list. So you could just use terms and just expand false. We like using UIDs because if you're looking at your explain, it makes it clear this is something that was replaced by a synonym and wasn't an original search term.
But that's another question I had was that you talk about the rare synonym problem.
Yes.
UID would probably make those more.
Well, if you use that, that's the UID solution actually solves the rare synonym problem because you no longer have rare terms.
Yeah, but what I was thinking is then you could basically take the actual search term and add a boost for it for that.
Yes, and that's the example.
Like make sure that your stroke comes.
If you did two fields, you could do that. Yes, if you did one field that was just a natural field, not synonym expanded, and you boosted the original query on that, and you had a second field that was synonym expanded, so you take your user query and you search both, boost the natural field, and then whatever comes out of your synonym field as well, or those together, and then you can kind of account for that too. So UIDs should still be your second choice. The graph filter factory at query time is still probably the best option if you can do it. It's fast. It doesn't cost anything in indexing, using the most flexibility. Yes.
Any implications of that in the very big text
The,
Define a very, very big file, I mean large.
mhm.
So there's no using zookeeper, so potentially the problem, right?
So what Solar's going to do is it actually brings the synonym file into memory, and it works from there. It doesn't read the synonym file every query.
Yeah, that's synonym graph is a vector. And the other thing is that if I from one entity I have really a lot of synonyms and implications and corrected format.
Yeah, so that's why I kind of set that ground rule, those performance graphs. So we used WordNet for this. I expanded that without filtering any non-word characters. We had like one, the numeral 1 and 1 were synonyms of each other. And so we got about 54,000 synonym sets with about 140,000 terms. So we had an average, each synonym definition had about 3 synonyms. If you have cases where your average synonym expansion is 15, 20 words, that's absolutely going to cost you more. At query time is you're going to do more terms in your queries. That's what Solar's good at, though. So you're going to see that that's not really a problem until you start getting out to 50 or 60 term expansions for your average. And I don't think most use cases fall into that. If it does, then go back to index time. Some questions? It's gonna mostly work okay. You'll get better results with the highlighter if you do query time expansion, but then the drawback to that is now you have to reindex whenever you change your synonyms. It might, yeah. Mm-hmm. But it does count positions. I haven't tried that on 6.1. We don't use much highlighting for our use cases.
What are limitations of duplicates within the synonym file? For example, jacket, you might want to look up tuxedo blazer, but if you look up tuxedo blazer, you don't want to look up jacket.
Yeah, so that's actually common for us because, especially with technical terms, they have the same first words. The filter factory is pretty good at looking at the next tokens, because what's happening is the tokens are being emitted by the tokenizer. The filter is collecting those, and there is a limited look ahead that it uses there. So sometimes you do have to play around with ordering to get it to match correctly. But it does a pretty good job of if you include, or the example used here, Yeti and Abominable Snowman, that came out of the WordNet file. If you put abominable by itself, it's going to find the synonyms for abominable. But if you say abominable snowman, it stops looking at the abominable synonyms and then goes to the abominable snowman Yeti synonym. Yes. Yeah. Yes.
So we have a curated list of synonyms.
Mm-hmm.
We have some ideas about how close the synonyms are to each other, right? So maybe Yeti would be an 80% substitution and Bigfoot would be 50%. How hard do you think it would be for us to incorporate that into the score rating? I would think probably the graphic and Gary and Sal. Does that make sense?
Yeah, I'm not sure if. So synonyms, like we were talking about earlier, they're really just brute force, replace tokens, let it go. If you want to really start getting a fine-grained control of your score based on the terms, the filters are probably not the correct place to do that.
So I guess what I was thinking was when it looked like you were offering substitutions in the query side where like either we're just going to use the span query for this phrase or this simple term.
Yeah.
Are there other places?
I mean, you could use the directory replacement and say that if they're searching for, like going back to our use case, with medical terms, if they're searching for cerebral vascular accident, they're looking for a cerebral vascular accident. Don't search for stroke. So cerebral vascular accident wouldn't have a synonym, but then stroke might have that directed replacement to say if they search for stroke, also consider cerebral vascular accident instead. But that's still mostly an on or off kind of solution. Yes. It does, actually. All those queries I ran for that 20,000, actually I was using Dismax for that. Now, if you go back, I think Solar 4, there were some issues with the way that Dismax was emitting the tokens that was causing it to not match multi-word synonyms, but that, I believe, sometime in the 5, early 6 timeframe was corrected. Yeah. The token, yeah. It just was working. But at least as of 6, it works just without any modification. Yeah. All right. Thank you, everybody.